Yes. So moving on to the third question. With reference to the equatorial low pressure belt, consider the following statement. So this is a question regarding pressure belt and it is regarding the equatorial low pressure belt. Absence of surface winds and presence of vertical currents are features of equatorial low pressure belt. Second statement says that it is a zone of divergence of trade winds. Which of the statements given above is or are correct? So, absence of surface winds and presence of vertical currents are features of equatorial low pressure belt. It's a zone of divergence of trade winds. So, regarding pressure belts, okay, if you want to study regarding the pressure belts, we know that we have an equatorial low pressure belt. We have a subtropical high pressure belt, subpolar low and polar high, subtropical high, subpolar low and polar high. So, this is the equatorial low pressure belt. This is the subtropical high pressure belt. We have the subpolar low pressure, again subtropical high pressure and subpolar low pressure. So, here we are going to see regarding the equatorial low pressure belt. We know that the wind always flows from region of high pressure to low pressure and applying Coriolis force, it gets deflected to the right in northern hemisphere and to the left in southern hemisphere. So, if you see the wind direction will be like this in northern hemisphere and it will be like this in southern hemisphere. So, these winds which are blowing between subtropical high and equatorial low, they are called as the trade winds. So, here you can see both the trade winds are converging. They are not diverging, they are converging towards the equatorial low pressure belt. So, please do remember regarding pressure belts, if it is a low pressure belt, mostly the winds will be converging. Let it be equatorial low pressure belt or let it be subpolar low pressure belt. So, moving back to the question. It's a zone of divergence of trade wind. No, it's not a zone of divergence. It's a zone of convergence. Okay, so just think low pressure means wind will be moving towards that. So it will be anyway the region of convergence. So you need not study if you don't, even if you don't know the concept or if you don't remember trade winds, etc. You can just apply that low pressure belt. It is a low pressure belt. So it will be convergence of winds. So second statement is wrong. Moving on to the first statement, absence of surface winds and presence of vertical currents are features of equatorial low pressure belt. Along the equatorial low pressure belt, we saw the trade winds are converging. As the trade winds are converging, they are moving towards the equator. We know that the temperature is very high at the equatorial region. As the temperature is very high, as the wind is approaching the equatorial region, the density of the air will start to decrease because the temperature is increasing. As the density is decreasing, the air will start to rise upwards. So along the equatorial margin, we have the rising of air. So as the air is rising at the centralmost region, we will be having a calm, stable, windless region which we call as doldrums. So the first statement says that absence of surface winds. No, yes, we don't have any surface winds because the air is rising. We have the vertical movement of air. No surface winds. There is no horizontal wind. Presence of vertical currents. Yes, vertical currents are there. Are features of equatorial low pressure belt. So, first statement is right. Second statement is wrong. So, there won't be any surface winds. There will be vertical movement of air. And along the equatorial low pressure belt, we have the convergence of wind, not the divergence of trade winds. That makes the second statement wrong. So, answer here is A. 1 only. The answer is 1 only. Moving on to the next question. With reference to the ocean currents, consider the following statements. The general movements of the currents in the northern hemisphere is anti-clockwise and in southern hemisphere is clockwise. In the lower latitudes, warm currents flow on the eastern shores and cold currents on the western shores. The North Sea, in spite of its location in higher latitudes, records high salinity due to more saline water brought by Labrador current. Ocean water movement is yet another important topic from where we can expect questions. In that ocean water movement, ocean current is the most important one because they are considered to be the most significant ocean water movement because they have an influence on the climate of that particular region through which they are flowing, because we have warm currents and cold currents. So in ocean currents, you need to study the location, the name, the type of different currents which are present on the different parts of the world. So here the first statement says that the general movement of current in the northern hemisphere is anti-clockwise and southern hemisphere is clockwise. If we consider the flow of ocean currents, okay, if you are considering the flow of ocean currents, okay, let's consider the ocean currents between the North America, South America and the Europe, Africa. Okay, suppose this is the North American region or the North America. Here we have the South America. Here we have the Africa. And here we have Asia. I'm just marking the currents of like this Atlantic Ocean. The currents of Atlantic Ocean. If you have to mark the warm currents, we have the Gulf Stream current over here. We have a Labrador current from here. We have a Norwegian current over here. And we have a Canary current over here. Along with that, we also have the equatorial currents like this. So if you see, along with that, one more thing, we have the North Atlantic drift as well. If you move to the southern hemisphere, we have the Brazilian current over here. And we have the Benguela current over here. If you have to just see the circulation, you can note that in the northern hemisphere, the circulation is in clockwise direction. In southern hemisphere, the circulation is in anti-clockwise direction. We call this circulation as the gyre circulation. So this gyre circulation results in different currents along different margins of the oceans. And these gyre circulation, where if it is moving, the branch of gyre circulation which is moving from equator to poles provides us with warm currents. This is moving towards from the poles to equator provides us with the cold currents. So if you see the question statement 1, it says that the general movement of currents in northern hemisphere is in anti-clockwise. And in southern hemisphere is clockwise. No, we have seen the general movement of the currents in northern hemisphere is clockwise, not anti-clockwise. And southern hemisphere is anti-clockwise. So the first statement is wrong. Moving on to the second question. In lower latitudes, warm currents flow on the eastern shores and cold currents flow on the western shores. Again, just recollect that figure of this ocean. You can see warm currents are on the eastern shore. Cold current on the western shore. That makes the second statement to be right. Second statement is right. Sorry. Third, the North Sea, in spite of its location in higher latitudes, records the higher salinity due to more saline water brought by Labrador current. In North Sea, Labrador current is basically flowing through the Labrador Sea. And secondly, Labrador current is a cold current. If it's a cold current, it is obviously going to decrease the salinity, not to increase the salinity. So this third statement is anyway wrong. So here, the first statement is wrong, second statement is wrong. The answer is 2 only. C is the correct answer. So just study the currents, their maps, their locations, and if you know the currents of different regions, you can simply put it like this. And please do study that along the lower latitudes, warm currents are on the eastern shores, cold currents on the western shores. Along the higher latitudes, majorly northern hemisphere, warm currents are on the western shores, cold currents are on the eastern shores. If you know this, like study it as a statement. So that is going to be helping you when you are trying to draw the ocean currents for the mains examination and all. So this is the answer C2 only.